the heart of these bombs. Atomic bombs. These were the first. They get their power from nuclear fission. What's fission? It means to split. Think of a very large, unstable atom, like uranium-235 or plutonium-239. These are heavy elements. Their nuclei are packed full, a bit wobbly you might say, ready to break apart if nudged. That nudge is the secret. So, how do you nudge an atom? You use a tiny particle called a neutron, fire this neutron like a subatomic bullet. When it hits the heavy nucleus, bang! The nucleus splits. It splits into smaller atoms, and it releases a burst of energy. Plus, crucially, more neutrons. Usually 2 or 3 more. These new neutrons are key. Those newly released neutrons are now projectiles. Each one can go on to hit another heavy nucleus, causing it to split, releasing more energy. And, you guessed it, more neutrons. This is a chain reaction. One event triggers 2, then 4, then 8. It snowballs incredibly fast. An avalanche of splitting atoms. All this happens in a microsecond. The result? A massive explosion. To make this work, you need enough material. Enough of that special uranium or plutonium. This is called the critical mass. Too little, and the neutrons escape. The chain reaction fizzles out. But with enough material packed together, the reaction sustains itself. It grows. The bomb design is all about achieving this, bringing subcritical masses together, creating that instant critical condition. Now let's talk about hydrogen bombs. These are also called thermonuclear weapons. Thermo means heat. Nuclear means, well, nuclear. These bombs are even more powerful. Much more powerful than atomic bombs. They use a different process, not fission but nuclear fusion. Fusion means to join together. Think about what our sun does. It's a giant fusion reactor in the sky. How does fusion work? Instead of splitting heavy atoms, fusion combines very light atoms, typically isotopes of hydrogen, like deuterium and tritium. These are special forms of hydrogen. Under extreme conditions they can merge. They fuse to form a heavier atom like helium. And in this process, guess what? Tremendous energy is released, even more than fission. Why is fusion more powerful? It converts more mass into energy. Einstein's famous E equals mc squared tells us this. Mass and energy are two sides of the same coin. Even a tiny bit of mass converted fully to energy is a huge amount of energy. Fusion is more efficient at this conversion. That's why H-bombs are so devastating. They tap into this deeper cosmic power. But there's a catch with fusion. It needs incredible temperatures and pressures, millions of degrees Celsius, like the core of a star. How do you get that on Earth? Here's the clever and terrifying part. You use an atomic bomb as a trigger. A fission bomb explodes first. This creates the intense heat and pressure just enough to ignite the fusion fuel, so an H-bomb is actually a two-stage weapon.